So what we want to see, what we want to look for, is the same things we looked for before. The first thing we want to do is establish the law of demand. Does the law of demand hold in our results? If it doesn't, something's wrong. But we can see that, for Pepsi, so here's the choice of Pepsi. The price of Pepsi is negative and it's significant, so that's good. That means as the price of Pepsi goes up, the probability of choosing Pepsi goes down. The law of demand holds. Our cross price effects should be positive, as we saw. So as the price of 7-Up goes up, the probability of choosing Pepsi should go up. So as the price of 7-Up goes up, people choose 7-Up less, the law of demand, and they choose Pepsi more. So that coefficient, that coefficient on the price of 7-Up is positive, which is consistent with theory, and it's statistically significant, which is good. Interestingly, this is strange, the price of Coke is negative, which doesn't make sense because Coke and Pepsi aren't complements. Remember what complements are? Complements are wine and cheese. Buy a bottle of wine and get some cheese and I enjoy them together. We don't go to the store and say, I'm going to grab a 2-liter bottle of Pepsi and I want to wash it down with a 2-liter bottle of Coke. That doesn't sound like human behavior. But that's fine. I mean, we're fine with unexpected results because they're insignificant. So it just means that, and again, this is strange in and of itself, it just means that we're not seeing a cross-price effect between Coke and Pepsi. Let's look at Coke, though. For Coke, price is negative and it's significant. Again, makes sense. For Coke and 7-Up, positive and significant. Again, it makes sense. As the price of 7-Up goes up, people choose 7-Up less and choose Coke more. The price of Pepsi is negative. Again, that doesn't make sense, similar to before, but it's not significant anyway, so it just means right now we're not seeing any cross-price effects between Coke and Pepsi. Could be the whole brand loyalty thing. You're either going to drink Coke or you're going to drink Pepsi. If I choose not to drink Coke, I'm not going to go to Pepsi. I'm going to go to 7-Up, exactly, and vice versa. If I choose not to drink Pepsi, I'm going to switch to 7-Up. So that's really what it's saying, is that there's not a whole lot of substitutability between Coke and Pepsi. You're either one or the other. There's going to be some. There's got to be some. We're not seeing it right now, though. And that actually makes sense. I mean, you guys, are you either Coke or Pepsi people? Doesn't matter to you?
I don't drink soda.
Yeah, me neither. But if you were to drink soda, it doesn't matter. You don't care. Yeah. No? All right.
But people
Well, it's
who
going to be
don't.
mixed with alcohol usually if you're going to drink soda,
it's
so it
gotta
really
be
doesn't
Coke.
matter.
But if you've got rum, you're going to get
It's a whiskey
Coke.
Coke, not a
Coke.
whiskey,
Exactly.
whiskey
Do
Pepsi.
you drink rum and Pepsi? That doesn't even sound right. It's rum and Coke. That's the name of the drink. These Cubans are going to be upset if you do that. Okay, so we can do our margins and predictions and all that stuff. Yeah, we can do that. So we got to predict. We can predict for individual outcomes again. And this is for Pepsi. We can evaluate at specific points. So this would be, and again, this is where, margins is really powerful, but you have to be really specific on what you're saying. So when I ran, let's go back a second. When I ran this command, margins predict outcome 1, what does this mean? Essentially what margins does is, if you don't specify specific prices and promotional aspects and all that stuff, then it keeps everything at its mean. So right now it's just saying at the average price of Coke, at the average price of Pepsi, at the average price of 7-Up, then the probability of choosing Pepsi is going to be 0.34, blah, 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 blah. But we normally want to be, as we saw in this last problem set, we normally have much more specific questions. So that's where we use the at feature. And this is now saying, okay, we're going to set, we're going to ask a specific question. And again, eventually we want to do these things graphically. We want that. We want pictures similar to that. This is asking a very specific question. If the price of Pepsi was $1 and the price of 7-Up was $1.50 and the price of Coke was $1.50, then what's the probability of a consumer choosing Pepsi? Notice it goes up a lot higher because Pepsi is cheaper, 7-Up and Coke are more expensive, so instead of on average having a probability of 35%, now you've got a probability of 69%. But we want to be able to answer these questions, not so much with these margins, but with a visual that's going to allow us to kind of see these results of the effects of our competitor's price on us and vice versa. And let's see what did I do here. I changed stuff around, so it doesn't really matter. Marginal effects is again looking at the slopes. We know that our probabilities are nonlinear. So in this case, we're saying, we're not saying anything. We're just saying what are the marginal effects of these prices. And again, implicitly, what margins does is evaluate marginal effects at the mean. So at the mean price of Pepsi, on average, when the price of Pepsi goes up by a penny or by a small amount, the probability of choosing Pepsi is going to go down by 59 percentage points. At the mean price of 7-Up, and actually at the mean price of everything, as the price of 7-Up goes up, the probability of choosing Pepsi goes up by 31 percentage points. And then at the mean price of everything, as the price of Coke goes up, the probability of choosing Pepsi goes up. Why Pepsi? Because we specifically said outcome 1, which is Pepsi. And again, these are at the mean prices, which we don't even know, by the way. We could get them, but we don't even know. We can get much more specific results by using our at function. Okay, what about a situation in which the price of Pepsi is $1, 7-Up is $1.50, Coke is $1.50. Now what are those marginal effects? What do small changes in prices do here? Now we can see that, small change in the price of Pepsi is going to increase the probability, it's going to decrease the probability of choosing Pepsi by 62 percentage points. Small change in the price of 7-Up is going to increase its probability by almost 30 percentage points, and a small increase in the price of Coke is going to increase the probability of choosing Pepsi by about 19 percentage points, all of which are statistically significant. Fairly large effects, depending, but again, we knew that. We know that effects are small here in the tails, and in this middle region, we're going to get much larger marginal effects. So the marginal effects depend on where we're analyzing this stuff. And we want to be able to visualize this stuff.
How did you choose or decide on the prices for each of them? Wouldn't you want to evaluate them at the same price?
We could, yeah. So we could, I was just kind of showing off. We can pick any. And this is how I show off at bars and stuff.
Hey guys,
Yeah. I show up with my laptop and I, hey baby, how's it going? Yeah, so we're just kind of showing how we can use margins. Let's just throw everything in there. So this is like the Heinz and Hun stuff. We got we got 3 brands of soda. We've got all the prices, we've got all the features. So this is our full model. And we get this nice, nasty looking output. We're gonna have all these iterations. By the way, it converged pretty quick, right? After 4 iterations. So, but we can check the same kinds of things. So for Pepsi, is the price of Pepsi, is the coefficient on the price of Pepsi negative? Yes, and it's significant. So at the very least, the law of demand holds for Pepsi. How about for Coke? For Coke, is the price of Coke negative and significant? Yes, it is. The law of demand holds for Coke. If we change the base, we can look at that for 7-Up. I'm sure I have it in here, but let's do it now. Boom. And image it there, so we can change base. I think you gotta specifically say base outcome. Let's use 1 Pepsi instead of 2, which is 7-Up. So we saw the results for Pepsi and Coke. We didn't see the results for 7-Up. Basically, we want to just make sure everything makes sense. Does the law of demand hold for Pepsi? Absolutely. The coefficient on the price of Pepsi is negative and it's significant. So again, we're comfortable with the law of demand holding. A lot of the other stuff is, may or may not be the right sign. So, for example, for 7-Up, we would expect promotion by 7-Up to be positive, and we can see that. Features positive. No, this is 7-Up. Features positive, but it's not significant. Display is positive, and it is significant. And for Coke, we can see that feature is positive, but not significant. Let's scroll down a little bit. And display is, for Coke, display is positive and it is significant. So things are looking normal. The cross-promotional effects should be negative. When my rival promotes, that should detract from the probability of choosing my product. That's not always the case. But some of those are not statistically significant. So again, we probably want to visualize this stuff. This is just a nasty app. Remember, let's see if one of you guys can do it. Interpret that value for me. What does that mean?
53.
What's that?
0.5.
Yeah. So the 0.5 on display code. So what does that tell me? It's a dummy, so it's a...
Code displays, there probably goes it's positive.
Nope.
Something relative to Pepsi.
Yeah, it's, so when Coke is on display, the relative log of the odds ratio increases by 0.53. Increases by 0.53. That's, the point is, it has no interpretation. It's just, we need to visualize it. We need to either convert these to probabilities, which is going to be equally problematic, but really what we need to do is we need to see this stuff. We need to see, when we're on display, are we getting a nice shift here, or is that shift really relatively small? One of the reasons why this may be, this one actually is statistically significant, but for which one is feature Coke, One of the reasons why this may be statistically insignificant is because it's on average, it's statistically insignificant. But it may be that on average it's statistically insignificant, but at some prices promotion is effective, at other prices it's not effective. So if it's effective at some prices and ineffective at other prices, on average it's ineffective. It could be, so that's why, these tables are virtually useless. We look at the signs, we look at the significance, but we really need to visualize this stuff to make it actionable. And again, the whole point of business intelligence is actionable insights. Can we help the firm understand what does and doesn't work? Can we help them allocate their promotional dollars more effectively? This is useless. This is on average. Average is what? The average depth of the ocean is what? I don't know what that means. Averages are horrible. We need to visualize this. More margin stuff. We can graph probabilities. So again, we're not going to do this, but if we do want to run this, so let's do a simple mlogit with just price, and we can graph Pepsi. We can use the predict command to save the results for Pepsi, 7-Up, and Coke, but we have to specifically say, outcome 1 is Pepsi, outcome 2 is all that stuff. We're not going to do this. So what this tells us is we've got the own price effect for Pepsi, probability of choosing Pepsi, and then those cross price effects for 7-Up. So as the price of, we'll get better pictures of this, but as the price of Pepsi goes up, the probability of choosing 7-Up goes up, and the probability of choosing Coke goes up. And so we want, again, these are kind of horrible visuals. The way to get really nice visuals is through the margins command. Margins and margins plots. So here's our big full regression. We can only do these one at a time. Set more off, sometimes that works, sometimes, you guys know what that is? When, let's see if it does it. I'm going to run this margins. I'm running it from $0 to $3.50 in 1 cent increments. And what I don't like is when, let's see if it does it. Yeah, it didn't do it here. So obviously this doesn't fit on one screenshot. So what set more off does, normally, I must have turned it off, is sometimes it'll do one screenshot and then it'll stop, and then you have to hit return to get the next screenshot, and so on and so on. And I don't want to see this stuff. I just spit out the results. What I want is the graph. So set more off, and because I probably use this all the time, it's probably set off permanently. What I want is the graph. Now we got a nice S-shape curve over the full range of prices. And again, it doesn't quite reach 1, but it gets pretty close. So this is kind of again, we can't call it a binary anymore because these aren't binaries, these are multinomial, but we can call it a probabilistic demand curve. And it obeys the law of demand. This one is for outcome 2, so basically I do the same thing, except I change price of Pepsi to the price of 7-Up, and I predict for 7-Up, which is the second outcome. So this will be our probabilistic demand curve for, again, we run one regression. Let's see that 10 times fast. And the margins, to get the different results, we changed the margins. Notice this only goes up to 0.8, so it doesn't go as high as it did. And let's get the one for Coke. And again, this is basically showing us the brand loyalty. Coke, let's see how high this one goes. Wow. It looks to me like Pepsi drinkers have the highest, that probability went up to the highest at 0. 7-Up went to 0.8 and Coke went to 0.6. Wow, that's strange. I actually thought Coke was the more, because more brand of the three, but it looks like Pepsi's the most brand loyal. Then 7-Up. And Coke. That's actually pretty interesting. Really interesting. Again, these are all separate. What we'd like to do, perhaps, is compare these probabilities together, which means we're going to have to run the margins, save the margins, and then combine the margins. So that's one of the limitations of margins is you can't put two together like this, because it would be nice to be able to, if you can slap them on top of each other, you can really measure. So let's do one that looks like that, and then one that looks like it's flatter like that. So what you can really do is say, okay, let's just take any price, and I'm going to pick that one where they intersect. And let's say this is $1, and let's go to 75 cents. So what happens if we, right, our delta here is 25 cents. What happens if we reduce price by a quarter? Well, you can see that the steeper curve is much more price sensitive, and the probability of purchase is going to increase for them a lot more than it's going to increase for the flatter curve. So, in my opinion, one of the best measures, and again, not everybody agrees with this, but in my opinion, one of the best measures of brand loyalty is, to me, the willingness of your customers to pay up. So in this case, it looks like these consumers are much more willing to buy your product when the price changes than these guys. So these guys, this flatter curve is less price sensitive. So let's call these guys A and these guys B. Who's more brand loyal? A or B?
Well, A is less price sensitive than they're going to be.
Yeah. So they're going to buy more, right? They're still going to buy more relative to, remember, they're both starting at the same point. They're going to buy more. The probability of them buying more is here. But these guys, right, they're jumping big time. So they're switching from something else to that product. So, yeah, the flatter, the more brand loyal, the steeper, the more price sensitive, and the less brand loyal. To me, that's the best measure of brand loyalty, is when you can put these suckers on top of each other and compare the slopes. We can kind of do that here, but margins is limited in that you can only graph one of these probabilities at a time. That's just a limit of the technology. There are some, if you kind of Google this and go into the Stata cyberspace dorkdom, whatever you want to call it, There are guys out there that have written some third-party add-ons that you can put into Stata that are supposed to be able to let you combine margins automatically. So you already looked at it?
I mean, no. I'm going to though.
Yeah, from what I've heard, I haven't tried them. I figured you guys are probably going to try them before I do, and you guys are having a lot of trouble getting them to work. So it's a common problem. Like I said, it's just the technology. But we're asking a lot from Stata. For one, it's doing a lot for us already. So having us generate these 3 graphs individually and having us combine them, all right, we can do that. We can merge files, we can do that kind of stuff. Let's not get greedy and have Stata do everything for us, right? Can you order pizza? How's your Bloody Mary?
I need another beer.
Yeah, exactly. We don't need Stata to do everything for us. We got to get paid to do some stuff. So we'll figure that out too. All right, so there's our basic commands for Stata, for multinomial logit. Let's take a look at our data set. So our data set is going to be those saltines. So I should have something called saltines. These are data sets. And the reason I like the saltines is because there's 4 as opposed to 30. We need that. And this is, think about this gets even worse. So this is IRI household panel, 136 households in Rome, Georgia, over 2 years. So I have no idea what Rome, Georgia is like. I don't know if it's in the sticks. I don't know if it's near Atlanta. We can probably Google it and see what it's like. So this isn't necessarily representative of the U.S., but it's representative of, it's one of our DMA's designated market areas. So
Why do they use that? Why wouldn't they use Atlanta?
Atlanta's probably in there. So the fact that they have more than, now you're just,
Sorry.
so,
Considering how expensive it is, you'd think they would just stick to the...
yeah, because I've done, I used
that's
Georgia as, I wrote a paper using data from Georgia, and I was told that Georgia was basically Atlanta. So the fact that they have Rome in here is interesting to me. But I was told that by Nielsen. And I can't remember if those guys lie like you. It's their job. So there's Rome. Do we see Atlanta anywhere?
Yes.
There it is.
Way
So it's not that close.
Holy crap.
Marietta's way closer.
Yeah. So that's strange. We have we got a thing here. This is 10 miles. So 10, 20, 30, 40. So it's 60 miles away. It's an hour away. I guess, again, I've never been through Atlanta, so I don't know what 60 miles outside of Atlanta looks like. I've been through Arkansas, and I know what it's like to be outside of the city limits of Arkansas, as in 1 mile outside. And it was, let's get the hell out of here, kind of creepy. It literally was. It was.
Apocalypse Now kind of
Banjo
people.
playing.
Banjo.
It was. Yeah. It was. Well, Deliverance. It was
Yeah,
Deliverance.
Deliverance.
It was. It was scary. We were looking at a map and I said, hey, it looks like we can cut across and save some time. If we take
Give us
this back
less
road.
words.
And all of a sudden, so we did, and the freeway turned into dirt roads.
Oh, gee.
And all of a sudden, all we saw, and I swear to God, it was rebel flags and just no, it just looked like 50 years ago. And it was me and my brother, two Mexicans driving in the backwaters of Arkansas. It was
Very sweaty.
I don't think it was hot either. I think it was during Christmas too. So I just knew we needed to get out of here because we were going from College Station, Texas to Chicago, and my brother was at the University of Chicago. So it's not like we were out partying. We were trying to get to school. It's like, oh my God, you idiot! Who told me to get off? Who told me to get off the freeway? All right, so here's our relative frequencies of our Nabisco, the brand leader. I mean, if you were to grab a box of crackers, again, these are specifically saltines, not there are tons of different kinds of crackers, graham crackers and all that stuff. These are saltines, which I like. Soup or something, I don't know. Nabisco, the brand leader. Surprisingly, the other one is generic. So it looks like Sunshine and Keebler are pretty close in their market share, at least. So we got a dominant player, and then we got this generic brand.
That's one generic brand or all generic brands?
It's all store brands, yeah. So it's going to be Safeway, it's going to be Lucky, it's going to be Rayleigh's. Yeah. So it's called literally store brand as opposed to the generic. These are just the percentages. Pie chart. Let's look at the prices. So here we do have some differences in the prices. In the expected direction, I always consider, and again, I don't buy crackers. I don't know if I've ever bought crackers, but I eat crackers. My wife does the cracker shopping, I guess. I do the beer shopping. But yeah, I would consider Sunshine and Keebler premium crackers, brands. I don't know. Nabisco is kind of the standard, and obviously private label is going to be the cheapest. So you kind of see that kind of distribution. What we think is true is probably pretty close. To me, saltines are saltines, so I don't think I would pay extra for Sunshine or Keebler, no matter how much I like the little characters in their commercials or whatever it is. Crackers are crackers. I actually noticed literally yesterday that my wife was eating crackers and they were saltines.